Hey guys, today we're going to learn how to write a system of equations based on word problems. Now for each of the word problems we're going to look at, you will be given two types of quantities. The goal when you're writing a system is to have one equation to represent one quantity and the other equation to represent the other. Now before I explain the rest of this that's in blue, let's read this question. It says, a local high school is putting on a school play. Adult tickets cost $20 and student tickets cost $10. If 58 people attended opening night, resulting in $900 in ticket sales, how many adults attended the school play? So in this particular example, the two quantities that are represented are A, the number of tickets that were sold, so adults and students, and B, the amount of money that was made. So first, we're going to make sure to label what each of these variables are going to represent in our system. So here, what I would do is that X, I'm going to make my variable X represent the adult tickets that were sold. And then I'm going to make Y equal to the student tickets that were sold. Now, it doesn't matter which variables you choose. You could have used A and S if that makes it easier for you to keep in track of what the variables represent. So A for adult, S for students, that's fine as well. You can use any variables, does not matter, because either way, the end goal here is to get that answer, which in this case is how many adults attended the school play. So we're not looking for both the variables, we're only looking to solve for, in this case, X. So first we need to write our system. Now our first quantity, as I mentioned, is the number of tickets that were sold. Now we have adults and students that attend for a total of 58 people. So that means that the adults plus the students is going to equal to a total of 58. Now the second equation will be the amount of money that was made. Adult tickets cost $20, so that's 20x, plus student tickets that cost $10 is going to equal to a total of $900. Now, we're only looking here to solve for x. You can use either substitution method or the elimination method. It does not matter. If you choose to use the elimination method, then you would want to eliminate the y's, so that way what you're solving for is the x and you don't have to do more work than you need to. Or you can use substitution since both of these variables here are by themselves. Now since I'm looking to solve for x, if I were to use substitution, I would want to use this equation here to solve for y, so that way when I rewrite the second equation and I plug it in, my second equation will only have x's, which is what I'm solving for. So that's the route I'm going to choose. So I'm going to use substitution method and I'm going to solve for y, meaning that I'd have to subtract the x, so y is going to equal to negative x plus 58. So now we're going to take this and we're going to plug it into this second equation here for y. So 20x plus 10 times y, which is negative x, plus 58 is going to equal to 900. We would distribute the 10, so 20x minus 10x plus 580 is equal to 900. We can combine the x's. 20x minus 10x is 10x plus 580 is equal to 900. We could now subtract the 580, and that would give me that 10x is equal to 320, and then divide the 10. So we get that x is equal to 32. And remember that this is not just the answer, we have to put it into context. X is 32, that's how many adults attended. the school play. Let's look at another example. We have here that Cassie and Gabriella are selling pies for a school fundraiser. Customers can buy apple pies and lemon meringue pies. Cassie sold 6 apple pies and 4 lemon meringue pies for a total of $80. Gabriella sold 6 apple pies and 5 lemon meringue pies for a total of $94. What is the cost of each of 1 apple pie and 1 lemon meringue pie? So here, since we're looking for the cost of each one, that means we would have to solve for both x and y. So I'm going to make x the cost of apple pies. And then I'm going to make y the cost of a lemon meringue pie. I'm just going to shorten that to lemon pie. So now let's write our equations. Our two quantities here are how many pies, or for how much money Cassie sold her pies for, and then our second equation is going to represent Gabriella's sales. So Cassie's sales are 6 apple pies, so 6x plus 4y, because she sold 4 lemon pies, for a total of $80. Gabriella sold 6 apple pies as well, plus 5 lemon pies, for a total of $94. Now again, you can choose whichever method you prefer here. In this case, if you were to use the substitution method, you try to solve for either x or y in any of these equations, you would end up with fractions, which is unfavorable to say the least. So instead, we may want to consider using the elimination method. If you notice here, the variables for x both have the same coefficient. The only thing that we need is for one of them to be negative. So I would multiply one of these equations by -1 so that I could eliminate those x's. Does not matter which equation you choose, I'm going to choose to multiply the top equation by -1. That would make that equation -6x minus 4y is equal to -80. And my second equation would not change, so that's just 6x plus 5y is equal to 94. Now we can add these equations together. The x's will cancel. -4y plus 5y is y is equal to -80 plus 94, which is 14. So we've already solved for y. Now, in order to solve for x, you're going to take that y value and plug it into either of those original equations. I'm going to choose to plug it into the top equation. So 6x plus 4 times y, which is 14, is equal to 80. 6x plus 4 times 14 is 56, is equal to 80. Subtract the 56 to both sides. We get that 6x is equal to 24. Divide the 6, and we get that x is equal to 4. So now to answer the question, what is the cost of 1 apple pie and 1 lemon meringue pie? The apple pie, costs $4. And the lemon pie cost $14. Let's try another one. This one reads, a music store sold a total of 27 used guitars and drums. Guitars cost $99 and drums cost $149. If the total sales were $3,223, how many drums did they sell? So here we're just trying to solve for how many drums were sold. We're not solving for both variables. So let's label what our variables would be. First of all, we have both guitars and drums, and both of these equations would represent each of these. So we want X to represent guitars, and we'll make Y represent drums. Now we're going to write some equations. The two quantities here that we're given, one is the amount of guitars and drums that were sold, and two is how much money was made from these sales. So the first equation would represent the total of guitars and drums. So that means that the number of guitars plus the number of drums is going to equal to a total of 27, as indicated here in the problem. In terms of the money, guitars cost $99. So we'll say 99x plus the drums cost $149, so 149y is going to equal to $3,223. If we're trying to solve for drums only, this is another example where substitution is a good way to go. Again, you can also use elimination. Whichever method you prefer, it does not matter. But just since we did elimination in the last example, we'll do substitution for this one. Since we're trying to solve for drums, that means that I want my second equation to have only y's. So I'm going to want to rewrite this equation so that it's x equals, etc. So that way, when I plug it in, I just have y's. Now, just keep this in mind. If you do not recognize how to do that, that's okay. You can solve for both. Just make sure that when you write your final answer, you are indicating how many drums were sold, not how many guitars were sold. And that's why we label our variables in the beginning, so we know what each one represents and we know how to answer the question appropriately. So we're trying to solve for y, so I am going to rewrite this equation as x equals negative y plus 27. Since in order to solve for x, I'd have to subtract the y. So now I'm going to plug this in for x here. So this is 99 times x, which is negative y plus 27, plus 149y is going to equal to 3,223. Now we have to distribute this 99. 99 times negative y is negative 99y, plus 99 times 27 is 2,673, plus 149y is going to equal to 3,223. Now we can combine the y's. Negative 99y plus 149y is 50y. Plus 2,673 is equal to 3,223. Now we have to subtract that 2,723. So we would get 50y is equal to 3,223 minus 2,673, which is 550. Divide by 50, and we get that y is equal to 11. So this means that 11 drums were sold. Now again, if you did not recognize that you can do it this way, so it's less work, and you solved for x, then you would have to take that x value and plug it into either of the original equations to solve for y. Let's look at our final example. We have here that Nicholas is a shoe salesman and he works on commission. This week, there is a special incentive to sell shoes and boots for a certain company. Yesterday, Nicholas sold 4 pairs of shoes and 6 pairs of boots, earning $128 in commission. Today, he sold 8 pairs of shoes and 3 pairs of boots, earning a total commission of $148. How much does Nicholas earn for the sale of each type of footwear? So we need to solve for both variables, and our variables here would be, I'm going to assign x to represent the amount of commission that he earns on shoes. And Y is going to represent the amount of commission that he earns on boots. Our two quantities here is that we're given his sales or his commission earnings for yesterday and today. So we're going to write one equation to represent yesterday's commission and a second equation to represent today's commission. So yesterday, he sold 4 pairs of shoes, so 4x, plus 6 pairs of boots, so 6y, and that's going to equal to a total of $128 in commission. Today, he sold 8 pairs of shoes, so 8x, plus 3 pairs of boots, so 3y, is going to equal to, he earned $148 in commission. Now we can use whichever method we prefer. However, this may be an example where using the elimination method would be the easiest way to go. If you'll notice that you can either cancel the x's or the y's, it does not matter which one you choose. If I choose to eliminate the x's first, I notice that this variable has, the x variable in the first equation has 4 as a coefficient, and in the second 8. So we want the numbers to be the same and opposite signs. So I could multiply this top equation by -2, which would make this into -8x. So that would cancel with the 8x here. So let's do that. We're going to distribute now the -2 to the top equation. So that would give us -8x minus 12y is going to equal to 128 times -2, which is -256. The bottom equation does not need to change, so I'm just going to rewrite it. 8x plus 3y is equal to 148. My x's here will cancel, and I'm left with -12y plus 3y, which is -9y, is going to equal to -256 minus 148, which is -108. Divide by -9, and we get that y is equal to 12. Now that we have y, we can plug it into either of the original equations to solve for x. So let's say I choose to plug it into the top equation. So 4x plus 6 times y, which is 12, is going to equal to 128. 4x plus 6 times 12 is 72, is equal to 128. Subtract the 72 to both sides, and we get that 4x is equal to 128 minus 72, which is 56. Divide by 4, and we get that x is equal to 56 divided by 4, which is 14. So now to answer this question, how much does Nicholas earn for the sale of each type of footwear? Nicholas earns $14 for shoes and $12 for boots in commission. And that's systems of equations, but from word problems.